I'm going to hand over now to Adrian Bertl, and Adrian is with B+. Adrian, you could go ahead and share your screen, please. Thank you so much for joining us. This is really great to have you. So Adrian, you've been with B+ for many years, and you have been involved in many roles from what I've seen. You've done product management, marketing management, and then you stayed in the marketing side. You went and you went into more you're leading the team there, from what I understand, right?
Yeah, yes. I'm more the technical marketing guy. I'm technician.
Everybody I've met at B+ is technical.
Okay. But we have even more technical guys there. Yeah.
Yes, there are. There's a level. There's a level of technicality. But yes, the people I've met from B+, extremely knowledgeable, and B+ has been in this industry for a very long time. So you've been in there since nearly the beginning of the whole ADAS world. So it's really great to have you here. I'm going to hand the floor over to you. I'll put myself on mute so I don't interrupt. But thank you so much for being here, and I look forward to the presentation.
Okay. So hello and welcome from me. I was jumping in for Alexander Noack, who handed over the presentation to me. He will, I think he is attending here. If you want to have contact to him, just search him at LinkedIn or contact me. I'll get you connected. What I'm talking about today is smart recording. But what is smart recording? I'm telling you something about the way about intelligent and efficient data acquisition in test drives. As we saw the questions before for Gwen, the million miles aren't always very sensible in the end of the day. You need some smart recording. You don't have to record everything. You do some smart recording. Let's have a quick overview about B+. Who is B+? As Ian said, we were founded in 1996. We have been in the ADAS market since 2002, 2003, when the first radar came into series production. There we did series software for the ECU, and we are now focusing on the tool chain for autonomous driving. So the recording, the analysis, and parts of the simulation. So hardware in the loop systems, especially there. We focused on camera, radar, and LiDAR technology, where the high bandwidths are. So let's look at a use case, the typical use case of recording data for ADAS and AD. Since ADAS and AD is the crucial part of getting information about roads and progress your algorithmics. The typical process is where you have some kind of collection. Afterwards, you're doing an ingest, and in the data center, you do everything. You store, detect, learn, do hardware in the loop systems, label your data, and filter your data, all in the data center. This is the typical, as we see it now in the market. Most people are doing that. So currently, all people are collecting everything. And if you see the camera sensor, single camera sensor resolution over the years and the bandwidth we are getting, the megabytes we are getting per sensor, per camera. And you have to see, you have more than one camera in the vehicle. It's extremely rising. And you have a vast amount of data, and the generation 6 is not the newest one. We are talking now about 8 to 16 megapixel sensorics, where you have to capture the raw data. And if you look at a typical setup, this is something we see in the market, which is very common today. There's even more sometimes, but pretty common is about 1.5 to 2 gigabytes per day per vehicle. This means you collect per day, per vehicle, 60 terabyte. And this is pretty a big amount of data. And you also always have to see, okay, I got it now, I got 60 terabyte per vehicle. If you have a fleet of 100 vehicles, it's 600 terabyte per day. Not all fleets are that big, but some are. And you have to manage this. Afterwards, what you do with the data, you can send them via the internet. what they currently do, they ship it physically on pallets. This is very efficient because you have nearly unlimited bandwidth. If you have one pallet of SSD drives, you can can transfer multiple petabyte of data, but the latency is a problem, and you're shipping data, you don't know what's in it, you just ship it, and you are not able to ship it out of, for instance, China. Afterwards, if you look there, you store, detect, learn, loop, label, and filter everything in the data center, where you have big machines, where you have cloud capabilities, where you have big machines to do detections, big storage systems. But what are the challenges there? If you look at the challenges of the typical process, this has risen tremendously the last years. Moving the data globally is a big problem, because if you look, for instance, if you collect data from China, road data from China, you're not able to move it out of China because of the regulations there, because it's something safety critical for them. Moving the data globally, in general, if you want to download 100 terabyte from India to Germany, it's pretty mess. Or if you want to transfer it to India or whatever, it would take extremely much time. And what is critical, if you see the complete industry is speeding up. They want to have smaller cycles. They want to have smaller learning cycles. The time to analyze it, so the time you capture the data to that you analyze the data, has to be shortened. This is pretty critical. And if you're collecting everything, the time to analyze is pretty hard. And you also collect duplicate data. So the 500,000 mile on the highway isn't interesting anymore for your traffic light detection or whatever. And you don't know what corner cases you have. You have one big data stream and you don't know what's in there. So there are also pretty hard cost drivers. The storage is, you have to maintain the storage. You have to rent the storage, for instance. If you're going to a public cloud, you have to host the complete systems. You have to pay the energy for that. At the same time, the same is for the processing. And you also have the time to analyze is pretty critical. And this is the cost driver, because your engineers are waiting for the results from the test drive, and you don't have anything there and they're waiting for that. What we were thinking about is shifting the processing the data at the source already, using smart data harvesting. So if you shift the process from the data set, some of the processes, some blocks, for instance, the detection, and the label and the filtering, into smart recording or intelligent ingest, so into these two intermediate processes, so that you are already select something in the vehicle. So that this would be the pre-processing part, which doesn't take part to this extent at the moment. This is our concept there. So if we look at the data, the amount of data, the upper ones are the meter data, the vehicle bus data, ECU and algo insights. What are ECU and algo insights? These are the statistics you get from the ECU, the RAM usage, CPU usage, processes, how the processes are doing. These are the algorithm insights. The vehicle bus is what the ECUs are communicating to each other. And the metadata is data about the data. So what is this about? So where did you drive, and what was the weather condition there? and it gains more and more. But these are only kilobytes. If you look at the big amount, the multi-gigabit data, you see you have to you see that with in the collection and the ingest, our concept is to reduce the data already before the ingest. So in the data center, you are able to work with the real valuable data, not the millions mile on the highway, but only the corner case you currently need to improve your algorithm or to train your neural network. So what we do in the vehicle, we do the analytics already, live analytics, the scene detection. So you're detecting a scene, for instance, if I want to have 100 roundabouts. So we are already able to detect this in the vehicle, that you can say, okay, I have a roundabout now. Now I want to record data, not any data, just the data I'm hunting for. Also, we are doing the data filtering, so we're able to, on this detection, we are able to filter the data accordingly, that you only get the real gold out of the complete rock. So we are able to filter out the real valuable thing. We're also able to do automated tagging, so you get some pre-tagged recording files that you know, okay, what's in it. I don't have a 100 terabyte blob there, and you're able to do some already tagged data, and then you, with your data management, you're able to filter and select what's interesting for whom. And we also can do some live processing of the data streams or cleaning of the data streams in the vehicle. How does this look like? So let's go to the concrete system. So we have a typical recording setup here, like it is in the vehicle if you have a bigger recording setup. We have layers like sensing layers where all the sensors are in. The conversion is done from serial interfaces to Ethernet to record it. There's also a distribute layer where you are able to distribute your data to the different platforms, and every data is concentrated to record it more efficiently. Then you have the data loggers or the data recorders, the recording software, and you also have maybe you have a storage area where you have a specialized storage in the vehicle. This you need especially if you're logging more than I would say 65 gigabit per second. So what we look there, what we have to change there. This is a typical recording setup like you find it in every vehicle nowadays. So what do we have to change there? We have to add the in-vehicle processing unit for raw data streams. So we have to get some of the data center capability with the server platform and GPUs in the vehicle. And the data streams have to be redirected out to this machine. So if you want to analyze anything you're recording in parallel, this has to be redirected very efficiently. And if you're having a complex setup now, you want to have a fleet management system, which is the next step for efficient operation. So you're able to roll out driving tasks. So I want to have roundabouts now. I want to have traffic lights now. I want to roll out the measurement configuration. I want to measure different things out over the air, of course. And you also want to have monitoring of the status. What's my progress? How much of my campaign has finished? Do I have 100 roundabouts for my algorithm department? So you're adding compute and fleet management, and this looks like that. If you're looking there, we have two areas, analyze and connection layer. The analyze layer is filled with the in this case the data links ATX4, which is a HPC for vehicles, where you can add up to 5 graphic cards for real-time processing and the software on that. I'll come to the software later. And the other one is to add a connection with a gateway and a cloud-based test fleet solution where you are able to monitor and configure your complete test fleet. So if you look some deeper again, and if you look how does this work like. I think. Okay, now you can see that. You see, we have a recording hardware there, the data logger. We have a LiDAR and a camera there. I simplified that. And you have a storage there. You saw that before. You have a recording software. You're getting source objects in some visualization or developer engine. And you're able to do with a translate object, send the data to the compute platform where you integrate a recording intelligence, and you're able to do analysis and detection in there. And the recording isn't influenced itself because it's separated hardware. You're able to do your detection on heavy algorithms, and you don't influence the recording in there. And the data is sent back to visualization objects. So you have the bounding boxes around the vehicles, and also metadata is generated. On this metadata, the visualization can trigger the recorder again if some case happens. So if a red light is detected or a traffic light is detected, it can trigger the recorder. So you have a very flexible system in there. If we dig one area deeper into the software, this is the same, but more on the software side. If you have a camera source, you got the camera, you do forward it to the Docker container there, where we have TensorFlow in there. We do analyze frames, detect objects. You're generating the metadata and the overlaid image there, and we send it back to the complete toolchain where the recorder runs at, and the recorder some JSON trigger decides if there are enough people there. And afterwards, it triggers the recorder control. So you only have the data you define you want to have to. And the data is also already triggered. So you're labeled. So you also know what's in there, what snippet is in there. Nowadays, you just have big files where you don't know, you know the vehicle where it comes from, but you don't know what's in there normally. And if you look, I got a video in there. I hope it runs smoothly. We see one vehicle, the source image is the upper one, and the lower one is the processed image. And the algorithm works as follows: we are detecting the people there, and if they move beyond this right line, we are detecting and triggering the recorder. And this is one example for how smart recording can work like. So if we look at now, we're jumping into the complete system on the cloud side. So if you see a test drive there, the active detection is already pushed to the cloud, where you can see, okay, we have active detections. You see how much of the data is valuable for you and what data is in there. And if you jump to a different view, you see the vehicle that has driven that. You see the session, the active sessions and the finished sessions there, and you're able to see the number of detections, and you see, okay, I'm finished with my job, I go to the next one. What is done classical in this area is normally that you're able to do manual. There's always a driver and another engineer that is labeling if it's rain, if it's night, if it's sun, or if it's fog. This can be automated with this tool completely. You're able to automate your complete data acquisition pipeline. in the end of the day. And if we sum that up, you're able to gain early visibility on data content with metadata, what you have currently not. You're able to filter duplicate data so that you only get the real data that makes sense to be stored and to be processed. And you also are able to update the filters in the vehicle, so you can deploy a new algorithm in the vehicle over the air. And at the end of the day, you reduce the data amounts for easier movement of data. For instance, if you want to get data from your test track to your data center, you don't have to upload this much. This makes your process faster. This makes you very, very, very easily going forward, because you know, okay, I have some very interesting corner cases for my algorithm, especially for level 3 or 4, it's very interesting. And you also are optimizing your visibility of your progress, and the management sees, okay, when are we finished with testing? So you are able to overview this complex progress. And I put a harvester in there. This is some simple image would be, we are able to separate the wheat from the chaff. So we are like a harvester, and we are able to do this smart data recording or smart data harvesting with an intelligent data pipeline. So we are putting intelligence into recording, which is currently not intelligent. And this was my presentation. Thank you for your attention. If you have any questions, just contact me or ask now.
There are actually a few questions. So
okay.
One question I would like to ask is, well, do you think how to put it, you had the harvester. Do you think the smart data harvesting will take part in all projects?
Excuse me?
The smart data harvesting or smart data recording, do you think that's going to be something that will be prominent in all future projects?
As we're working very, very long in projects, we know that not every tier 1 sensor maker or OEM is already there. But if you progress, if you continue to do some ADAS system, you get at the point, and the most ones are already at the point that they are not able to handle data anymore, or it's very, very expensive to handle data anymore. Yeah. And they want to get efficiency, because if we see one thing in the market, autonomous driving is very, very expensive in the end of the day. It will be a game changer, but it's very, very expensive. And they have currently the budgets are getting more tense, I would say.
Yeah.
And they want to get more and more efficient in data collection.
Well, I think the solution for ADAS specifically was, here's 1 million miles. We're going to have 10 cars driving around the world, and we'll do it efficiently as possible and collect as much data. That's not going to work for autonomous vehicles.
No.
So you have to be a bit smarter about what data you collect, how you collect the data. So your solution that you're proposing is extremely efficient and nice, and I really love it. The another question then related to that is the filtering, because at a certain point you're going to collect data, let's say using this technology. The algorithms are those something that we would, let's say an OEM would go to a university for, or would they go to the tier 1, or would somebody have to make their own algorithms?
This is what we are able to add. So this is an open system. So it's not exclusively B+ algorithms in there. Of course, we have some algorithms that are pretty good for pre-selecting, yeah. But we are open to add any standard algorithm or neural network to that. So we have currently it's something that's very, very open to anything. So as we start in this market with this very, very new concept, we know that not everybody, that somebody might have some filters, some triggers out there, and wants to combine it with our technology in the vehicle. So it's easy to integrate. This is what we are aiming at: easy to integrate, easy to start, easy to deploy.
What advice would you give somebody who is, okay, maybe they have created their own little computer and they've been hooking up and connecting USB cameras, and you know, they've been trying it out, and now they want to get serious, right? They're saying, okay, now we need to collect a lot of data, and the terabytes that you were describing. What would be your advice to them? What steps should they take?
Look at the quality of your data. So if you collect anything and you don't have a concept behind that, you're not looking into time synchronization, you're not looking into your data integrity. So if you have 2 USB cameras, you have it's hard to synchronize them. You have to use other technologies, so you're not able to realize a multi-sensor system.
Why is synchronization important?
Synchronization is important because if you're looking at the ADAS platform or an AD driving controller, in the end of the day, it's collecting all the data and fusing the data. And you can't do sensor fusion simply without time synchronization, without exact correlation of data streams. And if you're collecting crap, so every AI developer tells that to me, if you collect crap, the AI learns crap. Yeah. So if you're telling your kids nonsense, they will learn nonsense. And if you tell them quality things, they will learn quality things. This is just as simple as it sounds.
Yeah. Well, as an ex-product manager, I'm sure you are familiar with, you know, the tool that you create. It's your baby. And our next speaker, Thomas Olsen, who he has been creating. He is, I would say, the definition of an entrepreneur. So he's going to talk, and he's from a company called Einride, and he leads the autonomous software development team at Einride. So I'm very much looking forward to his view and what he has, his input in his presentation, because I think that's, you know, when you're in that leading role and you're creating software or you're creating hardware and software like you are, it's your baby, and you don't want to put rubbish into it.
Yes.
Just like an algorithm developer, you want to put good, clean data into it, and you're going to get good, clean results out. Yeah. So Thomas, are you with us at the moment?
Yes, I am. Really nice to be here.
Welcome. Adrian, I will thank you so much for the presentation. It was very nice hearing from you, and I'm glad you could join us.
Yeah, thank you for being here. Bye-bye.